In this video, we're going to be talking about measures of dispersion. Measures of dispersion give us an idea of how spread out the data is. One measure of dispersion is the range. That's the difference between the maximum and minimum values in the sample. The next measure of dispersion we have is the standard deviation. This is a measure of how far away data is from the mean on average. Let's look at an example here where we want to find the mean and range of each data set. So for our range, we need to identify the maximum and the minimum. And these are already in order from least to greatest. So our range here will be 4 minus 1, which is 3. And our mean is equal to 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4 over. Our mean ends up being 2.5. And the range and mean that we have for set B also ends up being the same thing. We still have a maximum of 4, we have a minimum of 1. If we add all of these numbers up, divide by the 8 numbers we have in here, we're going to get 20 over 8 again, or 2.5. So how do we differentiate between these two sets? Because we have some statistics about them that match. The standard deviation is going to give us a little bit more information about these sets. So which set would we think has the larger standard deviation? Since standard deviation tells us how spread out the data is, or it gives us an idea of how far away on average each value is from the mean, we would expect set B to have a larger standard deviation, so here our mean is 2.5. If we look at A, these values are pretty evenly spaced out. With B, we have a lot of values on the low end, and we have a lot of values on the high end. And it turns out that B does have a larger standard deviation. Now we're going to talk about how to find the standard deviation. So here we have two formulas to find the standard deviation. I'm going to call the first one formula A and the second one formula B. If you don't have a graphing calculator, you'll need to use one of these when finding standard deviation. And I know they look horrendous, but we're going to go through and explain what each part of these formulas means. Just note X bar here, that's referring to the mean, N refers to the size of the sample, and X refers to each value in the sample. Again, this capital Greek letter S, or sigma, it means add a bunch of things up, or take the sum. That's why it's the letter S, it's the letter S for sum. And so now we'll talk about how to use the two formulas. For formula A, the first thing we want to do is find the mean of the data. That was the X bar, part of the formula. Step 2, you want to subtract the mean from each value in the data set. That's the X minus X bar part of the formula. Step 3, square all values from step 2. So we take our X minus X bar for each value we've done this and square it. 4, add all the values from step 3. That's this part of the formula. Step 5, divide the sum from step 4 by n minus 1. So that's taking this and dividing by n minus 1. And then in step 6, you would take the square root of this. Now for formula B. First you would add up all the values in the data set. So this is sigma x. Then you would square the answer. That would be squaring it like this, and then divide the sum by n. So we would take this squared divided by n. For step 2, square each value, then add all of them up. So this is sigma x squared. Step 3, subtract the value from step 1 from the value from step 2. That's this. Step 4, divide the value from step 3 by n minus 1. And then step 5, we would take the square root of this entire expression. Now I know these formulas look kind of crazy. I will go over how to use the formulas. There will also be another video explaining how you can find the mean and standard deviation on your graphing calculator. As an example, find the range and standard deviation of this data set. For our range, we just have to identify our maximum and minimum values. So that would be 14 and 5. So our range would be 14 minus 5, or 9. Now for our standard deviation, we'll start using formula A. And in order to do that, we'll go back to what step 1 was. So step 1 says we need to find the mean. And in order to find the mean, we would add up all of the values and then divide by the number of values we have. So for step 1, our mean here is equal to, we can take the sum of all of these. The sum of all of these is 54. So our mean is going to be 54 over, we have 6 values, so 54 over 6, which is equal to 9. Now for step 2, we're going to subtract the mean from each value. Next, step 3 tells us to square all of the values from step 2. So we're going to take all these numbers we got and we're going to square each one. Next, step 4 tells us to add up all the values from step 3. So we add all of these numbers up and we end up getting 76. Next, step 5 tells us to divide this sum by n minus 1. So our n in this case was 6. So we divide by 6 minus 1. That's 76 over 5, which is equal to 15.2. Now step 6 says take the square root. So we would take the square root of 15.2. That gives us 3.8987. You should round to 4 decimal places. And that's equal to our sample standard deviation. So just again, this is the formula that we were using here. You can remember this in the series of steps, or if you become familiar with what each part of the formula means, you may not need to go through all of these steps. So, as you get to once you get to step 3, you can start to plug things into the formula and then solve that way and not need to remember it as a series of steps as long as you know what each part of it means. Now we'll look at this same example again, but we'll use formula B instead of formula A to see that we get the same answer. And then if you're not relying on the calculator, you can choose whichever formula you like better and solve that way. So the first step in B says to add up all the values, square the answer, then divide it by n. So if we add up all of these values, again we end up with 54. So that's sigma x. Then we want to square it. Then we want to divide this by n. Remember, our n was equal to 6. We simplify this and we get 486. So for step 2, we're going to square each x value and then add all of them together. We add all of these up and we get 562. Now for step 3, we need to subtract the value we got in step 1 from the value we got in step 2. And that gives us 76. Now for step 4, we need to divide the value we got in step 3 by n minus 1. Again, we get 15.2. Then for step 5, we need to take the square root of the whole thing. And again, we end up with a standard deviation of 3.8987. So again, this is the formula we were using here. You don't necessarily need to rely on going through every step in order. If you understand what each piece of the formula means, you can start finding values and plugging them into the formula and solve that way. Now let's look at one more example. Find the range and standard deviation of the following data set. So I would suggest pausing the video here, try to work through this problem on your own, then hit play to see me go through the rest of the solution. First we'll look at our range. These are already in order from lowest to highest, so our range is going to be 10 minus 0, which is 10. Now for our standard deviation, we can use either method A or method B. I'm going to solve this using method B because they didn't ask us to find the mean, and we don't need to find the mean in method B. In method A, we do need to calculate the mean, so if they already asked us to find it, that might be useful. But they didn't ask us to find it, so we can use B. But you can also do this using A if you want. So we'll set up a table here. We have x, 0, 2, and 10 are our values. And we'll write out the formula we're going to use over here. So for step 1, we add all of these values up, then we need to square it, then divide by n. So our sum here is 12. 12 squared is 144. Then we need to divide this by n. So this 48, we could substitute into this part of the formula. Now we'll move on to the next step. Here what we need to do is square each value, then take the sum. And the sum of the squares here is equal to 104. So we could take this 104 and we could plug it into this part of the formula. But we'll move on now. So we get 56. And now at this point we could pretty much just plug things into this formula. We take the square root of 28 and we get our standard deviation is equal to 5.2915. Remember to round standard deviations to 4 decimal places.